Welcome to Carlton's Math Corner. Today, we are going to talk about proportional and non-proportional equations. At this time, please make sure that you have your math journal, vocab packet, as well as something to write with. Our target today is I can determine if a graph is proportional or non-proportional. First of all, let's talk about what is a proportional relationship. Okay? A proportional relationship means that it fits a certain type of equation. And that equation is y equals k times x. And it's very similar to when we did slope-intercept form, we did y equals mx plus b. Well, proportional means that we don't have the plus b. There's no y-intercept, or the y-intercept is 0. And so that's why you can't see it. And the k is usually, where our slope is. That represents a number that is greater than 0. And so this line right here, do you notice that as if I choose just any point, any 2 points on this line, I should say, and let's make those a little bit bigger so you can see them. If I choose any 2 points on this line, if I find the slope, I notice that I run 1 and I rise 1. And so my slope is actually 1 because it's 1 over 1. So I know, and it's a positive 1 because this is a line of a positive slope. And so my formula, or my equation I should say, is y equals 1x. And I want you to notice that it crosses at 0. I can put plus 0, but we don't usually see equations like this. If we have a 0 at the end, if that's where our line crosses, usually we just see it, or we usually basically don't see it, okay? And so this equation is an example of a proportional relationship. It just basically means that this set of data and this set of data has a constant rate of change. And both sets of data started at 0. Okay? Let's look at another example. Here's an example where we're comparing weight to cost. So as the pounds increase, the cost in dollars also increase. And does this look like a proportional relationship? Yes, it does. You're right. Do you notice that, first of all, both of these sets of data, I know this is kind of hard to see and I'm so sorry, but both sets of data actually start at the dark line right here. This is actually 0. So they both start at 0. And if you couldn't see that, I want you to look at the equation. Notice that there's no number that follows the w, and that means that the y-intercept is 0. Okay? And so both sets of data start at 0. Then I notice that there's a constant rate of change. Even if I didn't know what these numbers were, I noticed that the line is straight and it's constantly rising at the same amount. Okay, and so here is the formula that shows me that it's rising at the same amount because the C represents cost, and just because it's a C, it still is similar to y equals 4x. I mean, it's the same thing. Remember, with variables, we can use any variable to represent our relationship. And the 4 is our slope. It's telling me that for every 1 that I run for weight, I rise 4 in dollars in costs. Okay? And so this is a proportional relationship. okay, because it fits both of the criteria. Now look at this one. What is different about this? Why is this a non-proportional relationship? Well, there's a couple things that make this non-proportional. First of all, what I notice is neither one of the sets of data start at 0. Okay? And the next thing that I notice is that this is not a straight line. I mean, this is definitely, oops, I know my computer will make a straight line, but I'm trying not to. See, no matter what I do, it makes a straight line. This is not a straight line though. This has definitely got a curve to it. Maybe if I just draw with a pen, maybe it won't make. Oh, good. See, it's a curve. That means that there is not a constant rate of change. And if you notice, if I run here and rise, that is 1 over 1. If I run here, rise, that's 1 over 1. But look at this one. This one's 1 and 2, so 2 over 1. This one is 2 over 1. So yes, there's some repeat, but it's not a constant rate of change. Okay, so this is non-proportional. It doesn't even fit both criterias. Okay, what I want you to do is I want you to look at these 4 other graphs. And I know some of them have data that go along with it, just so that you can see what numbers were plotted. And so what I want you to tell me are, are they proportional? Are they not? And can you tell me why? Why do you think they're proportional and why not? Okay. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.